Hi Precalculus students. Today we're going to take a look at Chapter 9. In Chapter 9 we worked with polar coordinates and polar equations, and so let's go ahead and get started. For number 1, it says graph and name 3 other points that represent the same point as 2, negative 60. Keep in mind, 2 is the r value and negative 60 is your theta value. The distance, r is the distance from the pole and theta is the angle measure. Okay, so you can either do this graphically, but most of you like using this rule over here. We can find 2 other points by using these rules. The first one is 2, negative 60. If I want to keep the same r value, then I'm going to take my angle measure and either add 360 degrees or subtract 360 degrees. Okay, if I take negative 60 degrees and I subtract negative 60 degrees, then I'm going to get an angle that is smaller than negative 360 degrees. So I don't want to do that. What I want to do is take negative 60 degrees and add 360 degrees, which would get me 2, 300 degrees. So now, we always have 2 positive r values and 2 negative r values. So if I want to find the negative r value, or the opposite of the r value that I have right here, I'm going to take the angle measure and I'm going to add or subtract 180 degrees to that angle measure. So if I did negative 60 plus 180 degrees, I would get 120 degrees. And if I did negative 60 minus 180 degrees, I would get negative 240. And then you know that I would use 2 pi or pi in place of 180 degrees or 360 if my given angle measure, if my given point was in radians. All right, in problem number 2, we're going to find the polar coordinates given the rectangular coordinates. Now, keep in mind, polar coordinates are Polar coordinates are r, theta, that's how we identify polar coordinates, and rectangular coordinates are x, y, which is what we're used to. We learned about all these rules over here, or these equations. These equations are super helpful when we are converting from polar to rectangular. All right, so if this is a rectangular coordinate, this is the x value, this is the y value. I can do this a couple different ways. The first thing I'd like to do is probably graph it. If I were to graph this, 0, 4 is going to land right here. I know that the r value is 4, the distance from the pole is 4, and that angle measure right there is 90. So that's where I get 4, pi over 2. If I take a look at this one, remember, keep in mind, this is x and this is y. And so if I were to graph these and draw a right triangle, x is negative root 3, y is 1. If I did Pythagorean theorem, and then I took the square root of it, I would get, if I took the square root of negative root 3 squared plus 1, I would get an r value, I would get an r value of 2. So my r value is 2. And then in order to find that angle measure, I can use tangent, which is opposite over adjacent, and I know that in the second quadrant, the tangent of 5 pi over 6 is equal to 1 over negative root 3. I didn't have to use tangent. I could have used sine or cosine and gotten the same answer as well. And then work through C the same way. Remember, if I draw a right triangle, label each of those legs 2, this is 2, that's 2, and did the Pythagorean theorem, I would get a value of 2 root 2, and then did the tangent of that angle. I would tangent of what angle in quadrant 1 is equal to 1? Well, that angle would be pi over 4. Okay, so for number 3, it says find the rectangular coordinates. Remember, rectangular are x, y of each point with a given polar coordinates. So they tell us that this is r and this is theta, and I need to find x and y. We'll keep these last 2 equations in mind. X equals r cosine of theta, y equals r sine of theta, and that's exactly what we do. If we plug in those values and simplify, we end up getting negative 3, 3 root 3. And we're going to do the same thing for B, and we're going to do the same thing for C as well. Just keep in mind that these values, you need to find those values from the unit circle. So you guys need to know your unit circle values in order to get those numbers right there. Okay, in question number 4, it says write the rectangular equation in polar form. If I'm going to write an equation in polar form, I want r's and thetas. I do not want x's and y's. So I need to get rid of the x's and y's and convert them to r's and thetas. So in order to do that, what I'm going to do is use these equations that I have on the side over here. So let's see, x squared plus r squared, this looks familiar. X squared plus y squared is equal to r squared. R squared equals 9, and then if I took the square root of both sides, I get r equals plus or minus 3. So this is in polar form because it doesn't have any x's and y's, it only has r's or thetas in it. If I take a look at problem B, y equals 3, well, I know y is equal to r sine of theta. So I'm going to replace y with r sine of theta. And then if I divide both sides of this equation by sine, I get r equals 3 sine of theta. And then 1 over the sine of theta is cosecant of theta. And this equation right here, if you guys remember, is going to be a line if we graphed it. This equation, and just like this equation right here, is also a line. Isn't that a horizontal line? Same thing with this one. If I graph this, this is going to be a circle. Just like if you guys remember, this is a circle in rectangular form. Then this last one over here, if I took x squared plus y squared, that would give me r squared. Y, I know, is r sine of theta. If I factor out the r, I end up with r times r minus 2 sine of theta. And then set each of those equal to 0, I get that equation right there. And then this is going to be a circle that's not centered at the pole. It's going to be centered off to the side. It's going to be centered above. It's going to cross the, not y-axis, theta equals pi over 2. All right, and then number 5, write each polar equation. Now we're going from r's and thetas to rectangular form. We want x's and we want y's in our equation. So let's see, r equals 4. If I squared both sides, I know that r squared is equal to x squared plus y squared, and this would be a circle. And that's exactly what this is if I were to graph it in polar form. For part B, I can rewrite this as the tangent of 5 pi over 3 equals y over x. And I know that from this equation right here. And then if I go back to this, let's see. The tangent of 5 pi over 3 is equal to negative root 3. And then if I multiply by x on both sides, I get this right over here, which is a line with the slope of negative root 3 over 1. And so is this right here. It is a line if I were to graph that. Don't forget, you can't graph that on your calculator. You have to know that that's just a line that goes through the angle 5 pi over 3. And for this last one over here, I'm going to take and rewrite secant as 1 over cosine. And don't forget about leaving that negative 4 there. And then multiply both sides of the equation by cosine of theta. R cosine of theta, well, I know that that's equal to x. X equals negative 4. This is also a line. This is going to be a vertical line. And this will also be a vertical line if I were to graph that.